Imagine a time before our planet existed. A time when the solar system was young, a chaotic swirl of dust and gas left over from the birth of the sun. This vast cloud, known as a nebula, stretched across unimaginable distances, filled with the raw materials that would one day become our home. These weren't just any particles, they were the remnants of ancient stars forged in the heart of nuclear furnaces and scattered across the cosmos. These particles, mostly hydrogen and helium, swirled and danced, their movements governed by gravity, the invisible force that shapes the universe. Within this swirling nebula, something extraordinary began to happen. Gravity, ever so slowly, drew these scattered particles together. Over millions of years, these particles collided and clumped, their individual movements merging into a slow spiraling dance. As more and more particles joined this cosmic ballet, the cloud began to shrink, its rotation accelerating like a spinning ice skater pulling in their arms. The center of this maelstrom grew denser, hotter and brighter, eventually igniting into the star we know as the Sun. But the story doesn't end there. While the Sun blazed at the center of this nascent solar system, the remaining dust and gas continued to swirl around it. This material, the leftover building blocks of the solar system, orbited the Sun in a vast disk, a cosmic carousel of potential. It was within this disk, billions of years ago, that our planet began to take shape. This primordial cloud, though seemingly chaotic, held within it the seeds of order, the blueprint for planets, moons, and asteroids. The stage was set for a grand performance, a billion-year drama that would see the birth of our world.
Let's journey back in time about 4.5 billion years ago to the early solar system. Picture a swirling disk of dust and gas orbiting a young, vibrant sun. Within this disk, gravity continued its work, pulling together particles that collided and stuck together. Over millions of years, these tiny particles coalesced into larger and larger clumps like pebbles growing into boulders. These rocky bodies, drawn together by gravity's relentless pull, crashed and merged, their impacts generating intense heat. As these collisions continued, a young molten Earth began to emerge from the chaos. Imagine a planet covered in fiery oceans of molten rock, its surface constantly bombarded by asteroids and comets. This early Earth was a violent and unforgiving place, far different from the world we know today. Yet even in this inferno, the seeds of our planet were being sown. As Earth grew larger, its gravitational pull increased, attracting even more debris from the surrounding disk. This bombardment contributed to the intense heat, keeping the young planet in a molten state. Heavier elements like iron and nickel sank towards the center, forming Earth's core. Lighter elements like silicon and oxygen rose to the surface, forming the planet's crust. Over time, the bombardment slowed as the solar system began to clear. The young Earth, still incredibly hot from its formation, began to cool. This cooling marked a turning point in our planet's history, setting the stage for the emergence of oceans, continents, and eventually life itself. As the early Earth cooled, a remarkable transformation began to unfold. Imagine a planet covered in fiery lava flows, its surface slowly solidifying into a thin, rocky crust. Volcanoes erupted across the globe, spewing gases from the planet's interior into the nascent atmosphere. These volcanic gases, a toxic mix of water vapor, carbon dioxide, nitrogen, and other compounds, formed a thick, steamy atmosphere around the young Earth. As the planet continued to cool, the water vapor in the atmosphere began to condense. Imagine torrential rains, unlike anything we see today, lashing the Earth for millennia. These rains filled the low-lying areas, forming the first oceans. The oceans were not the pristine blue we know today. They were likely a murky, greenish-brown color, filled with dissolved minerals and heated by the still cooling crust. The formation of oceans had a profound impact on the Earth's atmosphere. Water, a remarkable solvent, absorbed much of the carbon dioxide from the atmosphere, locking it away in rocks. This process, over millions of years, led to a decrease in atmospheric carbon dioxide and a corresponding increase in nitrogen. The early atmosphere, though still lacking significant oxygen, was beginning to resemble the air we breathe today. It was during this period, in the depths of these primordial oceans, that life is thought to have emerged. From the simple ingredients of water, organic molecules, and energy from the sun, the first single-celled organisms arose, forever changing the course of life on our planet.
Around 3.8 billion years ago, in the depths of the primordial oceans, life began. Imagine a world without plants or animals. A world where the only living things were microscopic organisms, single-celled pioneers in a vast watery wilderness. These early life forms, known as prokaryotes, were incredibly simple, lacking the complex structures of later cells. Yet they possessed the remarkable ability to reproduce, passing on their genetic information to the next generation. These early organisms thrived in the warm, mineral-rich waters of the primordial oceans. They obtained energy from the chemicals spewing from hydrothermal vents, volcanic fissures in the ocean floor that released heat and dissolved minerals into the surrounding water. This process, known as chemosynthesis, sustained the first ecosystems on Earth. Over millions of years, these early life forms evolved and diversified. Some developed the ability to capture energy from sunlight, a process known as photosynthesis. These photosynthetic organisms, called cyanobacteria, released oxygen as a byproduct of their metabolism. This oxygen, initially a waste product, would eventually transform the Earth's atmosphere and pave the way for the evolution of more complex life forms. The emergence of life in the primordial oceans marks a pivotal moment in Earth's history. From these humble beginnings, from the simple act of replicating molecules, a vast and interconnected web of life would eventually emerge. The stage was set for the next chapter, a chapter filled with evolutionary innovation, diversification, and the rise of increasingly complex organisms. The story of life on Earth is a story of constant change, adaptation, and diversification. For billions of years, single-celled organisms ruled the planet, their tiny forms evolving and adapting to the ever-changing environment. Then, around 600 million years ago, something extraordinary happened. Life took a giant leap forward with the emergence of multicellular organisms. Imagine the first multicellular organisms, simple clusters of cells working together, a far cry from the complex plants and animals we see today. These early multicellular organisms, like their single-celled ancestors, lived in the oceans, their soft bodies leaving few traces in the fossil record. Over millions of years, these early multicellular organisms continued to evolve. Cells became specialized, taking on specific tasks within the organism. New body plans emerged, from the radial symmetry of jellyfish to the bilateral symmetry of worms and insects. The oceans teemed with a diversity of life, from sponges and corals to mollusks and arthropods. This explosion of life, known as the Cambrian explosion, marked a turning point in Earth's history. It was during this time that most of the major animal phyla, the basic blueprints for animal body plans, first appeared in the fossil record. The stage was set for the evolution of increasingly complex and diverse organisms, culminating in the reign of the dinosaurs.
The Mesozoic era, spanning from 252 to 66 million years ago, is often called the Age of Reptiles. It was during this time that dinosaurs, a group of reptiles that evolved from earlier archosaurs, rose to dominance, ruling the Earth for over 180 million years. Imagine a world vastly different from our own, a world of lush forests, vast deserts, and warm, shallow seas. Dinosaurs, with their unique adaptations and impressive size, thrived in this environment, evolving into a dazzling array of forms. The Mesozoic era is divided into three periods: the Triassic, Jurassic, and Cretaceous. The Triassic period saw the rise of the first dinosaurs, small, agile creatures that shared their world with other reptiles, like the mammal-like reptiles called cynodonts. As the Triassic gave way to the Jurassic, dinosaurs diversified and grew larger, some, like the long-necked sauropods, reaching colossal sizes. The Cretaceous period witnessed the peak of dinosaur diversity. Giant herbivores like Triceratops and Stegosaurus roamed the land, while fearsome predators like Tyrannosaurus rex and Velociraptor stalked their prey. The skies were filled with pterosaurs, flying reptiles that soared on leathery wings, while the oceans teemed with ichthyosaurs and plesiosaurs, marine reptiles that had returned to the water.
Let's embark on a journey through the Mesozoic era, a time when dinosaurs ruled the Earth. Imagine yourself walking through a lush Jurassic forest, the air thick with humidity and the sound of insects buzzing.
Towering above you are the mighty sauropods, their long necks reaching for the tops of the tallest trees. These gentle giants, some exceeding 100 feet in length, were the largest animals to ever walk the earth. Venture into a Cretaceous swamp where the air hangs heavy with the smell of decay. Here you might encounter the armored Ankylosaurus, its body covered in bony plates and spikes, its tail ending in a massive club. Or perhaps you'll catch a glimpse of the fearsome Spinosaurus, its crocodile-like jaws lined with sharp teeth, its back adorned with a massive sail. Now picture yourself on a dry, dusty Cretaceous plain. The ground shakes beneath your feet as a herd of Triceratops thunders past, their massive heads adorned with 3 horns and a bony frill. Suddenly, a Tyrannosaurus rex emerges from the tree line, its massive jaws agape, its tiny arms held close to its body. This apex predator, one of the largest land carnivores of all time, was a force to be reckoned with. The Mesozoic era was a time of incredible diversity and adaptation. Dinosaurs, with their unique physiology and behaviors, ruled the Earth for over 180 million years, leaving behind a legacy of fossils that continue to captivate our imagination.